First of all, I would like to thanks Dr. Garg Saab for giving this opportunity to present the views of Praj Industries on this advanced biofuel in India's energy transition and how the global links has been connected and very recent what we can say connected to the dots of Global Biofuel Alliance as a sustainable aviation fuel is a common platform where all the developing countries and global south is going to play a major role, and India is going to lead that as we have the great potential to work. Before going in detail with the subject of today's discussion, I'd like to just give the introduction of Praj Industries, what we are, and so as a landscape, we are say more than 100 plus countries operating on the biofuel sector, as well as say more than 1,000 plus projects executed across globe on different biofuels. More than say now 400 plus patents on different technologies, and as a global lead in this technology sector, we are not only the technology and engineering company, but we are as an indigenous technology EPC company for the sector to grow. Very core businesses we are having. We are not only say in transport fuel, but we are also in the aviation fuel technology. We are also in the gaseous technology. We are also in the marine technology. We are good EPC players for this. Then we are having modularized plants, manufacturing hubs across India. And of course, the backbone is strong R&D, which is Asia's largest R&D center for the biofuel development. Now coming to SAF, if you see the SAF as a topic, the major topic in previous session also described on the GHG emissions. What GHG emissions are going to be play a major role in climate change after this COP30 is going to be announced. And in 2019, if you see, the 1.2 billion tons is the what aviation says, and 2050 is going to be 3 billion tons of CO2 equivalent GHG emissions for the aviation sector. And of course, the net zero requirement, what we are emphasizing as per IATA fly net zero scenario, in June 2022, they declared that expected global SAF requirement to achieve net zero is tremendous. And we see that not say 5% or 6%, but more than say now 10% CAGR is emerging in SAF sector. And if you go with the developmental plan of India as a country, of course, the indicative mandate has been given that 1% tentative by say 2027 and 5% by 2030. So we as a technology engineering company or as a country, we are geared up for the demonstration and scalability of the factors, which are going to give India as a hub for production of sustainable aviation fuel. Of course, there are certain challenges which are the opportunities for the India to grow in this sector. Yeah, CAGR, if you say 10%, if I keep, then it's domestic and international. If you see the demand, roughly say today is 7.2 to 4.2, but 2050 it is going to be 9.6 to 6.4. So roughly 15 to 16 million metric tons of per annum requirement of overall sector. And India, if indicative mandates, if you see from 1% to 5%, the KTPM means 1,000 tons per annum requirement is going to be more than say 1,000 crore liters by 2050. There are different feedstocks what has been considered for the SAF production throughout the value chain of the what we can say farm to fuel models, where you will see that HEFA is the route, co-processing is the route, then your UCO collection. But after taking all the raw material which is existingly low hanging fruit in country, we found that still there is a gap of say 5 to 6 million metric tons of SAF production, what is going to be required to meet the demand which is going to be the mandate by Corsia or ITA or ICAO. Now if you see which are the different pathways just for the general applications, that but most of the people get confused how much pathway and maximum blend can be happen in jet fuel with the sustainable aviation fuel. If you go with the standards of ASTM D7566 and their annexures, what they have mentioned in the Corsia, and of course ICAO is guiding that one. So somewhere it is say 10%, somewhere it is 50%. So cap, everybody knows that 50% we can blend. But which are the pathways that can be afford to blend with its carbon footprints and generating good income for the country, not only for say stakeholders like industry, but also for the farmers. So basic is that we have to go with the model which is giving us socio-economic and environmental benefits to the country, which considered raw material from the farmer's prospect, which can consider the raw material or process or technology which is giving a circular economy, creating that impact in overall sector. So if you see that STM D7566 Annex 5, we assume that alcohol to jet is one of the pathway after co-processing or using UCO, HEFA, which is a low-hanging fruit right now. But for the HEFA, we have to create a lot of raw material potential in country. Alcohol or ethanol is a very clearly visible pathway. And we can see that if we gone through the products like molasses to ethanol to SAF, or molasses to isobutanol to SAF, or if we qualify corn as a raw material which is low carbon feedstock production for the processing of SAF, it is going to be the win-win situation for all. Now why we say that alcohol to jet is having the best potential? Because presently if you see the EBP 20, we already on the milestone of 1700 crore liters capacity building, say 1100 crore liters production is happening, and capacities are now installed beyond 2000 crore liters. Plus additionally a lot of new raw material is coming out for the production of ethanol, like sweet sorghum, sugar beet, cassava, and parallelly that is say 21 to 2200 crore liters of capacities. But if you visualize that 2G ethanol is also picking up. So agriculture crop residue roughly say 240 million metric tons, which is surplus available, is having the potential to create another 20% ethanol blending program. And in qualification criteria, crop residue to SAF is already qualified in all pathways, in all countries. So Europe is having its own mandates to create, say, 10% reduction in the overall process compared to jet. But if you see that other markets like US, Global South, they are not having that mandate to say 10% reduction overall, but it says that it has to be from renewable. So if you read properly the RED 3 or your LCFS, Reno Bio, and SAP mandate by Corsia, so India now requires very especially that we should create a mechanism to calculate the life cycle assessment of the SAP production. Secondly, we required what we can say institute to certify these carbon credits to be evaluated and properly justify for the product. And third, most important is that our feedstock should be categorized under the low carbon feedstock. So agri residue is qualified, but when we go with the grain to ethanol to SAP, our cropping percentage is roughly say 30% higher than the Brazil, what they are producing. and where we have to play a very major role by developing, say, intercropping models or reducing the overall footprints of feedstock. So, adequate ethanol availability is the potential of India, where we can say 25-27% blend, and beyond that, applications for the sustainable aviation fuel is a key. Though we can say it is slightly higher in the capex right now to produce alcohol to jet because of number of steps involved, but potentially it is having the best low carbon footprint if we go with this residue model. Now, what Praj has discussed with the different countries, governments, and all, our aim is very clear to make it more sustainable and economically viable. So, in that sector, we thought that, okay, alcohol to jet technology is not demonstrated anywhere in the world as a single plant. So, we build our own pilot plant to produce ethanol, to convert it into SAF, and demonstrated to the globe that yes, integration plant can be happen in such way that energy integration is the key in overall process plant, and where we see that to meet all the standards, last time we flew the flight from Pune to Delhi sector, where testing facility of two parameters crucially for the SAP is not available in India. So those labs should be get installed into the our ecosystem to test SAP qualified for the blending into the jet. So if you calculate the life cycle assessment, one part is your feedstock integration, second is your energy process integration, and third one is your application. So feedstock technology product and its application is the model what we have to very carefully understood and then implement what is the best engineering technology we can integrate into the system. Feedstock, technology, product and its application. So for C molasses, we calculated the different sector. If jet fuel is say CI means carbon intensity number gram CO2 equivalent per mj, it's a jet fuel is 89. If you go with the base case that okay, I'm just simply using C molasses and converting into ethanol and then jet, then it's coming down to 53 because considering molasses as a waste. If I use the biorefinery concept, sugar biorefinery concept, where press mud to CBG to green hydrogen, and that green hydrogen will be used for the production of SAF, then it is coming down to 42. And if I go with the co-located plants, just like a bolt-on models, it is 40, it is coming roughly 40. And of course, next technologies are like CCUS and CCS, it is going down to -6. So it's very clear that from the 89 to -6, India can achieve in coming next 2 to 3 years by considering say 1% blending, which can be happen with the co-processing, but for the 5% blend, we require this roadmap to be very structurally positioned in front of ICAO and Corsia. If I go with the 2G ethanol route, agri-residue route, if same principle applied to the process, then from 89 it will go to -21. But minimum target we can say that 25 is what we can achieve easily, which is cleared by the Europe to import the SAF. Secondly, we can export as a SAF hub to rest of the countries and developed countries also. For that, we also come out with the modularization of the process block, so that integration will be easy and it will give us a very sound benefit over whatever the capex loaded across globe for the production of 1 liter of SAP. So balance measure is the process block. So here we come out with the modularized concept where all the equipments will be on the skid and setup. It will reduce all the parameters what we considered as a capex and opex point of view for the production of SAP. So roughly say 30 to 35% capex reduction is happening when you go with the modularization. These are some of the basic photographs how the modular concept is working for this SAP, because SAP production is not we can say very strong innovative things. All the processes are used in the refineries, but integration of those with few technology interventions are the keys. Here the major challenge is to reduce the capital investment and make it much more viable. If you go with the saving, of course, on-site labor cost we can save say 75%, which is the major working capital we required. Construction will happen in a very fast way because already we are having say large manufacturing hubs in Mangalore, in Kandla and all. So there we can structure the things and what we can say install at wherever the sites are. And previously we have done same business for the oil and gas for different sectors where most of the international customers they adopted and saved a lot of money in their installations. So this philosophy we created, and touch wood very soon we can install good projects across globe where the inquiries has been generated. So overall if you see as an emerging field there are challenges, but we considered those challenges as an opportunity. So feedstock development where we see that sugarcane intercropping with the sweet sorghum. So sweet sorghum is a dedicated crop for the sap. From the same sugar industry, the sap production can happen. If we go with the starch-based industry, we have the cobs or we have the straw that can be converted to 2G ethanol and further, of course, for the SF production. In technology parameters, we focus to integrate the entire thing where value proposition makes a sense, and engineering has been done for the modularization. Of course, the product, not only SAP is produced, along with that we can play the role that, okay, renewable diesel is another byproduct which is coming out from the process, which is again a supportive for the National Biofuel Program. Renewable naphtha, which is having a strong market. So you can play within say 50% SAP, 50% rest of the products, 80-20, 90-5-5. So that twist can be played as per the requirement of the market. Just like Brazil is playing the same thing in sugar refinery to produce sugar or ethanol. That is how they used to play. And thirdly, of course, the application part, not only say SAP is there, but tomorrow something went wrong, what the process can tweet to the biochemicals, process can tweet to the ethylene, process can tweet to the different range of, you can say, polymers, which are biopolymers. So that is how the biorefinery will play a crucial role rather than setting up a standalone SAP as an industry. And of course, from the residue point of view, as I mentioned earlier also, that 2G ethanol process, which had given as a very strong product of low carbon ethanol, but lignin to biobitumen, which is very strongly we came out as a technology. And from that raw lignin, we purified the bitumen, and road has been constructed in country first road with the blend of say 10% bitumen into the fossil bitumen and with the CRMB process also. So both the blends, very soon we expect a notification to come out for the same. So if you see what the sector requirement is, that there is a tremendous potential of say above 9.6 billion, but the steps towards the country to achieve as a global hub is very potential considering the raw material availability and technology which is indigenously available. So with that, I can say that manufacturing hubs are ready, technology is ready, mandate is going to be there very soon, and with that gear up, that all the energy transition can be happen very smoothly. What we thought that in 2030 and 2050, India can be the hub for the total energy transition to supply or export the products what we build indigenously. Thank you.